welcome back to tutorial 12. Here we're going to just have a little chat about basic tuning into a dummy load. The slide shows a radio transceiver, an ICOM 706 transceiver, connected to an antenna switch, and the antenna switch can switch the transceiver to the antenna, or it can switch the transceiver to the dummy load. Many radio amateurs use an antenna switch like this, others don't. What they have to do is they have to use a patch lead if they want their transmitter connected to a dummy load. They would use a patch lead for that. Then when they've tuned up their transmitter or done whatever test they have to do, they would then connect their transmitter via the antenna switch to the antenna. Of course, you're going to have other instruments in here as well. You're going to have an SWR meter probably in this location here before the antenna switch. The dummy load absorbs when the transmitter is switched to the dummy load, which is just 50 ohms. Recall that the impedance of all transmitters just about is 50 ohms. When a transmitter is connected to 50 ohms, as it is when it's switched through to the dummy load, all of the power arriving at the dummy load, which is just a large 50 ohm resistor, is dissipated as heat and there is no radiation. And this dummy load can handle up to 1.5 kilowatts. If you're transmitting into a dummy load, there is no need to identify it because you're not radiating any power, or you are radiating a tiny amount. If you had an amateur that lived down the street, he could probably hear you. But when you're transmitting into a dummy load, there's no need to identify your station, and you can test as long as you like. If you're doing tests into an antenna, you need to identify your station. I'm not going to go into the protocols prior to transmission. That's well and truly covered in the practical component of this course. But for now, if you're transmitting on air, you need to identify, and we've got here a dipole antenna with a balun. I'll talk to you a little bit about that balun in a moment. When we're transmitting on air, we need to identify when we're going into our load. We do not have to identify our station. A balun is an impedance matching device. Remember we talked about coaxial cables being balanced and unbalanced? Well, we're using coaxial cable here as our interconnecting cables. So we're using unbalanced cables. A dipole antenna is a balanced antenna. So if I just draw the dipole here, that's that dipole I've drawn here. And we're feeding it with coaxial cable. If I can draw that. So that's round cable with a conductor in the middle. And normally we'd put one conductor on there and the other conductor on that side of the antenna. But the problem here is that this is unbalanced. And the antenna is balanced. A dipole antenna is balanced. A balun allows us to connect something that is unbalanced to something which is balanced. The dipole antenna is balanced. It's balanced because the impedance of each leg of the dipole above ground is the same, so it's balanced. So we need to put a device here called a balun, and the balun gets its name from the words balanced and unbalanced. That is a balun. And that's what this device is here. A balun does two things. You don't need to know how it works. Balun does two things. It matches impedance if impedance matching needs to be done. And it also enables us to convert from a balanced line to a balanced antenna or vice versa. That's it for dummy loads and balanced and the basic tuning up procedure. Cheers for now. This is Ronald VK to take care.